So previously, we look at firms' cost of production, and we know that typically uh, firms has a total cost function, average cost function, average variable cost function, and the marginal cost function. And these curves typically look like U-shape. So average cost, average variable cost, and marginal cost. Marginal cost pass through the minimum point of average cost and the average variable cost. Now we want to put these firms into the market and and see how the firms behave in the market. So the market we will look at is called perfectly competitive market. So in this market, we have a large number of small firms. So which means each firms they are small relative to the market. They are price taker. They do not have a market power. Secondly, products are homogeneous. The product you produced and is the same as the product I produced, so there's no differentiation. Thirdly, there's free entry and access into the market, so it's easy to enter the market or leave the market. The implication of this is that in the long run, each firm profit must be zero, because if it's a positive profit, there will be more firms enter the market, and that's going to drive down the profit. If there's a negative economic profit or economic loss, then some firms will leave the market, and that's going to increase the profit until it reaches zero. And we also implicitly we also have perfect information here. So everybody knows everything, and everybody knows that everybody knows everything, so on and so forth. All right. So in this market, we have a market supply and demand. So demand is downward sloping, so that's the market demand, and supply is upward sloping, and we should know that this market supply curve is the sum of individual firms' supply curve. Okay, so in this market, the equivalent occurs in point E, where the supply intersect demand. That means the price of market price of PO, market quantity of big QO. Okay, that's the market. So each firms, they are small relative to the market, so they can sell as many products as they want at the market price. They cannot charge higher prices because people will walk away. Consumers think your product is exactly the same as the products other suppliers supply. And if I'm the firm, I cannot charge a higher price because consumer will walk away. I do not need to charge a lower price. So because I can sell as many as I want at the market price. So this market price is then also my marginal revenue curve, or that's the demand for my product. That's the and demand for my firms. Demand for, not market demand, but demand for my firms. So if I sell one more unit of output, I get extra P0 revenues. So that's a marginal revenue. So we call this market diagram, and this is firm diagram. Okay, so under firms, I'm faced with this market equivalent price. So what I want to, now the problem I'm faced with is how many units of output should I produce so as to maximize my profit. So I'm going to follow MR equal MC. So I have MR curve, which is horizontal at the market price. MC curve upward sloping. MR equal to MC. I'm going to produce at this point. This is called little e. At this point means quantity of little QO. Okay, produce little QO units output. Okay, so firms will follow MR equal to MC to maximize. So to maximize profit, so which is PQ minus total cost. Okay, and this implies, as illustrated in our diagram here, optimal unit output is QO. So given that I produce QO unit output, the total revenue, we can read it from a diagram, which is the area. Each unit output, I'm going to sell it at a PO price. Altogether, they are QO units. So it's PO times QO, or it's just the rectangle, or QO E PO. It's this rectangle area. Okay, where's my total cost? To get total cost, go from quantity up to the average cost curve. Read out the average cost. Let's call it CO. So the total cost now is the area of O, Q, O, and I'm going to call this little f. F, CO. So that's the size, the area of these rectangles. And we see that the profit is the difference. That's the profit. And we can see in my drawing here that the profit is positive. So the firms are making positive economic profit. So that's short run. In the long run, because of free entry exits, which is this color. In the long run, because of free entry and access, and everybody see that the firms in the markets are making positive economic profit. So there will be more firms enter the market. And that means this supply curve will shift to the right because there are more suppliers in the market. Now, since the profit is driving the firm entries, and as more firms enter the market, supply curve shift to the right, and the market equivalent price decrease. So as the market equivalent price decreases, firms revenue decreases, and it's in the end the firms are profit decreases. So the firm entry will drive down the profit, and it should be, the entry should occur such that each firms in the market earn zero economic profit. Okay, so which means that the profit must be at least level. At least level. Oh, which means that the the price must be at the minimum point of average cost curve. You know that the minimum point of average cost curve is the note that the marginal cost intersects the minimum point of average cost. Okay, so it should be at this point, so which means Q1 that correspond to output Q1 and price level of CO. So this is CO. So the entry should be such that this supply curve shift to this called S1. Okay. So supply curve shift to S1. Equivalent price drop to CO, and firms produce Q1. The market equivalent, the market quantity, equivalent quantity is equal to Q1. So the number of firms now is equal to big Q1 divided by little q1. And previously, this called is M1. Previous, in the short run, the number of market is called N0. It's Q0 divided by little q0. Okay. So that's the short run and long run behavior of the firms in a perfectly competitive market. Okay. Now, so we have used this market diagram and the firm diagram to describe to describe firms' behaviors. What about, let's say, we have the typical, the standard cost function. So demand, supply. So let's start from a long run equilibriums where every firm earns zero economic profit. Suppose two tasks here actually for you to practice. First, starting from a long run equilibrium. So if for some reason you the only firms in the market, if you have a technological progress, such that your cost you become more cost effective, which means your cost function decrease, your cost shift down. Okay, compare with other firms, and let's hold all the other firms' cost function constant, the same. What happened to your profit? You can see that now, given that you are more cost efficient, you are going to earn a positive economic profit now. And so one implication of operating in a perfectly competitive market is that, okay, you should do your best to be cost effective. Okay, that's first task. Second task to you is that, okay, let's say if there's a shock to the market, for example, demand side shock. That shift, which shift demand to the left. For example, if this is a market for this is a market for coffee, and there's a decrease, and the shock is that there's a decrease of tea price. Okay, and coffee and tea, they are complement to each other. So decrease and tea price increase the demand for tea, decrease the demand for the coffee. So demand for coffee shift to left. What happened? In both short run and long run.